Hello, in this video we're going to be taking a look at the chain rule, which some of you may know as a function of a function, but it's the same thing, it's the same method, it's the same exercise. And what we're going to be doing is we're going to be solving some differential equations by using substitution. It's actually easier to show you than to describe really. This is the function we're going to be using, this is the formula that we're going to be using. So let's move on and do some examples. So we can see here in example number 1 that we've got a function here, something to solve, an equation, we want to solve it, differentiate it. I've put the formula there in the corner just as a reminder. But what we've got here is we've got a function within a function, or we've got something we have to do first before we do the next link of the chain, hence the terms that are used. If you see here, we can't solve this to the power of 7 until we've solved what's inside. So basically we have to do this bit first before we differentiate it. As I say, it'll make more sense as we do it. So let's have a look. So what we need to do is, we're going to use substitution, and we're going to take this bit inside, and we're going to let u equal everything that's inside. So that's 2x to the 4 plus 6x minus 12. Okay, straightforward. Now if we look at our formula, we've got dy over du and du over dx. Now y now equals, because we've substituted u into its place, now equals u to the 7. So if we do this first part of the formula and say dy over du, because the variable's u, we're going to get very simple differentiation, 7u6. Okay, and then if we do the second term, the du dx, so that's this piece here, so that's going to be du dx, and you can see the format here. What we've got is this is a u, so that's what we're looking for, that's our dependent variable, while x is an independent, so that always goes on the bottom, the u on the top. Same thing happened here. An independent variable is the u, and the dependent variable is the y, so that goes on the top and bottom. Okay, let's do it. So if we solve this one, we've got, so 2x to the 4 is simply going to be 8x to the 3 plus 6. And the 12 is a constant, no x there, so remember anything with no x just disappears, goes to 0. Okay, so now we're going to bring these back together as per formula. So that gives us, so this is going to be our dy over dx. This is where we were aiming. So we've got 7u to the 6, which all multiplies this. I'm going to put this in brackets for clarity. 8x 3 plus 6, close bracket. Now obviously this doesn't make any sense because we've got a u here then where our variable is x, but we happen to know what u equals, and u equals this lot here. So I can substitute that back in. I'll just move this board up a bit. Give myself some space. Okay, so substituting in for u, we now have 7, put u in brackets, so that's 2x to the 4 plus 6x minus 12, close bracket, all to the power of 6, don't forget your powers, all times the derivative of 8x to the 3 plus 6 And that's that one done. Simple as that. So that one is solved. So we have a solution now. We have the derivative of this first term up here. Okay, that we started with. So now we can put any value of x in and find out what the gradient is at that point. So moving on to example number 2. So here in example number 2, we've got a different function. We've got the exponential e to sine x. Remember that e stands for 2.718, okay, which is natural base of natural logs, or the base of natural logs, should I say. Okay, same principle. So we're going to say let u equal. So what we're doing again is we're looking for the thing that's the inner function, the first thing that be done, which is this bit here. Now a lot of calculators put this in brackets, which I think is correct really. And that's what we're looking for. The clue is the thing that's in the inner bracket. So it's sine x. So we're going to let that u equal that sine x. The part we'd have to do first. That now means that y now equals e to the u. So if I solve these as per formula, so dy over du, well, world's easiest differentiation is e to the u, or e to anything. So it's just that. And then we've got the derivative of the other part, which is the du dx. So that's the derivative of sine x. Easy one. Cos x. So nothing complicated about that. Bring them back together as the formula. So we've now got dy over dx equals e to the u times cos x. Okay. Again, u makes no sense, so we have to sub back in for u. We know that u is sine x, so we have e to the sine x times the cos of x. And that's that one done. So moving on to example number 3. So looking at this example, we've got y equals sine 2x. Now you're probably aware there's already a standard derivative for this that's often in the derivative tables. And sine of 2x, you simply bring the 2 out to the front as a multiplier. The sine becomes cos, so you end up with 2 cos 2x. Okay, let's see by doing this method if this ends up to be the case. Let's see, we should get the same result if it's correct. So let's have a look. So this one, simply going to go, that's messy. Let the u equal stuff inside the bracket, 2x. Okay, that now means that now y now equals sine of u. Okay, so if I do my derivatives, dy over dx, du, sorry, will give me cos u. Nice and straightforward. And the derivative of the second term, du dx, is simply going to give me, so it's the derivative of 2x, which is simply 2. So I'll bring them back together as the formula states, and we now have dy over dx now equals, so we've got cos of u times 2. Now if I bring the 2 to the front, because that's a standard convention, put the numbers at the beginning of the functions, of trig functions, like thus. Okay, substitute back in for u. U is 2x. And there we have it. It worked as expected, as hoped. Let's have a look at another example. Now this one, I want you to have a go at it yourself. So pause the video, have a go, see how you get on, and then I'll work through it with you and we'll see if you get the same answer. So just pause your video at this point. Okay, welcome back. Hopefully that worked okay for you. Let's see if I get the same answer. I'm sure we do. It's not difficult, this, is it? Okay, so we're going to go, I'll just turn the pen on, we're going to let u equal, again, the stuff inside the bracket, the inner function, so that's 2x. That now means that y now equals natural log of u. Okay, so if I do my derivatives, dy du equals, and if you remember, the derivative of log of x, or the log of u, is 1 over x, or u. Whoops, careless. Okay. U. It's my fault for introducing the word x into the conversation. Okay. And then the other term, du over dx equals, so that's the derivative of 2x, which is simply 2. Bring them back together. So we've got dy over dx equals 1 over u times 2, which gives us 2 over u. Or, subbing back in for the u, we've got 2 over, so u equals 2x, so we've got 2x. Now we've got 2 over 2 here, so that will naturally cancel down to 1 over x. And what you've got there is another standard derivative. So if we take a look at, where's my pointer? So if you look at this one, where are we? This one here, we've got 2x. So regardless of what the value is of k there, the k being a constant, some number in front, some coefficient actually, it could be 2, could be 20, could be 2 million, could be 2 trillion, it doesn't matter what it is, you'll still end up with 1 over x. Okay, and if you go through this process, you'll see that happens. So there's a standard derivative. So you'll always get 1 over x. So hopefully that worked out for you okay, that you got the same answer. You might have maybe forgotten to do the cancelling out, but you can see how that works out. Now on this one, just shuffle it down a bit. I want you to have a go at these yourself. So what you'll need to do obviously is pause the video, have a go at these 5 and see how you get on, and then on the next slide I'll give you the answers, the solutions. Okay, so pause the video now and have a go. So how did you do? Did you get these answers? Okay, fairly straightforward. The first one is straightforward, second one straightforward. Interesting here, you also get another standard derivative really. Whatever's, when you've got e to a power, whatever's there to the power, you always end up with a derivative of that at the front. Okay, these next three are quite handy to remember as well. What you've basically got is the derivative of the x, the term in front of the x, the derivative of the x goes on top. So this one we had 2x. Obviously the log just becomes 1 over. So it all moves down and then you end up with a 2 over the top like that. This one, because it was a minus 2 in front of the x, the derivative of 2x has become minus 2. This one, same thing. This one was a power. It's become 2 times 2, so it's become 4. So hopefully you got the same answers, and if you did, well done. And if you didn't, just have another go at them. It's not difficult, just keep working on it. Thank you.